Welcome to Lesson 3.4, Algebra Properties Used in Geometry. So the big idea for this lesson and our goal is to just make sense of that idea that properties from algebra and arithmetic can be applied in geometry. So our properties that you've been learning throughout middle school and earlier in high school can also be applied to geometry. So just a refresher of a few of these properties. The reflexive property of equality simply states that anything is equal to itself. So 3 equals 3, -4 equals -4, etc. The symmetric property of equality says if A equals B, then B equals A. So if 2x plus 4 equals y, then, or equals 4y, then 4y equals 2x plus 4. We can flip what's on the equal sign sides. And then our third property is the transitive property of equality. So the transitive property of equality states if A equals B and B equals C, then we can say A equals C. So if two things are equal to the same value, then those two things are equal to each other. So if x equaled y and y equaled z, then we could say x equals z. So you're dropping that repeated part. So if we go to example 1, if 1/2 equals 0.5 and 0.5 equals 50%, what could we conclude using the transitive property? So if 1/2 is 0.5 and 0.5 is 50%, we could drop that repeated part of 0.5 and set the others equal, so we could say that 1/2 is equal to 50%. Then we have the postulates of equality in operations. So the addition property of equality says if A equals B, then A plus C equals B plus C. And the multiplication property of equality says if A equals B, then A times C equals B times C. Now, these properties include the inverse operations of subtraction and division. So the addition property of equality, because subtracting is technically adding a negative, this could also be A minus C equals B minus C. And the multiplication property, the fact that dividing is technically multiplying by a fraction, this could also say if A equals B, then A divided by C equals B divided by C. So the multiplication property of equality includes division, and the addition property of equality includes subtraction. The of equality just means it happens on both sides of the equal sign. So in example 2, it says show the postulates of equality and the operations used in solving 50x minus 8 equals 120. So to solve that, we would add 8 to each side, which is the addition property of equality. Then we're left with 50 times x equals 128. So to solve for x, we're going to divide each side by 50, which is the same as multiplying by 1 over 50. So we call that the multiplication property of equality. So then x would equal 128 over 50. In example 3, and just so you guys know, in example 3, I write it out as a 2-column proof. So you'll get more comfortable with 2-column proofs, but on the left are our mathematical statements. On the right are the reasons for that. So example 3 says, suppose that the measure of angle AVB equals the measure of angle CVD. What can we conclude using the addition property of equality? So we first know AVB equals CVD. That was just a given statement. So using that addition property of equality, we could add angle BVC to both of these, which then would tell us that angle AVC, the measure of AVC, is equal to the measure of BVD, because AVB plus BVC creates AVC, and then VVC plus CVD creates BVD. So what we could conclude would be this piece here, that the measure of AVC is equal to the measure of BVD. Because what we're doing is adding that BVC to each side. Then we have our postulates of inequality and their operations. So the postulates are the same as our properties of equality, except for now we're dealing with inequality symbols, meaning the less than, the greater than, less than or equal to, or greater than or equal to. So the addition property of inequality and the multiplication property of inequality, just like earlier, they include the inverses of addition and subtraction. The new property that we're looking at here is the transitive property of equality. So the transitive property says if A is less than B and B is less than C, then we could say that A is less than C. So our example here, if -5 is less than -2 and -2 is less than 7, then we could say -5 is less than 7. The addition property of equality says as long as we're adding or subtracting the same thing on both sides of the inequality, we're allowed to do so. So if a -4 is less than 2, then a -4 plus 10 is less than a 2 plus 10. And the multiplication property of equality, if A is less than B and C is greater than 0, then AC is less than BC. If A is less than B and C is less than 0, meaning C is a negative number, then AC is greater than BC. So if we're multiplying or dividing by a negative, you're looking at the bottom. If it's multiplying or dividing by a positive, we're looking at the top. So if 2 is less than 4 and C is 3, then 2 times 3 is less than 4 times 3. If A is less than B, meaning -3 is less than 1, and C is a -2, then the -3 times -2 would be greater than the 1 times -2. So then example 4. Show the postulates of inequality and operations used for solving 7x plus 17 is less than 31. So first things first, we'll be subtracting 17 from each side. So subtraction being the inverse of addition is the addition property of inequality. Then we're left with 7 times x is less than 14. So divide both sides by 7, which is the multiplication property of equality, giving us x is less than 2. Then just a reminder, if you're multiplying or dividing by a negative, you're going to end up flipping that inequality sign. So moving down, we have the postulates of equality and inequality. So it first states for any real numbers a, b, and c, the equation to inequality property says if a and b are positive numbers and a plus b equals c, then c is greater than a and c is greater than b, which you can see the example right above it. The substitution property says if a equals b, then a may be substituted for b in any expression. So if a was x and b was 5, but a and b were equal, we could substitute that 5 in place of a or x. Example 5. In the figure at the right, the measure of angle JMK equals x plus 37. The measure of angle KML is 2x minus 12. And the measure of the whole large angle, JML, is 73. In part A, they want us to find x. So I know that angle JMK plus KML added together equals 73. So I can take x plus 37 plus the 2x minus 12 and set that equal to 73. Combine like terms on the left, and we have 3x plus 25 equals 73. Subtract the 25, divide by 3, and x equals 16. Now that we know that x is 16, we can figure out the measure of angle KML. KML was the expression KML should have been 2x minus 12. You'll see here I accidentally solved for JMK. So I put this in for JMK, 16 plus 37 is 53 degrees. If I were to solve for KML, I would put 16 into the 2x minus 12. 2 times 16, 32, minus 12 tells me angle KML is 20 degrees. Then example 6, our final example for this lesson, says angle TRS and SRP form a linear pair. So if we know those are a linear pair, then we also know the measure of TRS was 3a plus 5, and the measure of angle SRP was 2a minus 25. Find the measure of angle TRS. Well, we know TRS and SRP are a linear pair, meaning they add to equal 180 degrees. So I can take the two angles added together and set them equal to 180. That allows me to solve for my variable of a. So then when we solve for a, we combine like terms on the left. So we end up with 5a minus 20. Add the 20 to each side. So 5a equals 200. Divide by 5, and a equals 40. But the question was not what is the value of a, it's what's the measure of angle TRS. TRS was the expression 3a plus 5. So we're going to substitute 40 in for a. So 3 times 40 plus 5, 120 plus 5 gives us the measure of angle TRS, which is 125 degrees.